All right, I wanted to go ahead and take a look at the practice exam that I've laid out for you. And I've repeated quite a few questions from before because you're going to see that I repeat questions on the real exam that I give you. So I wanted to run through all these answers and just kind of go through some things. So question number one, we have this little ticker tape timer. We've done this problem before, but I like to review it. And we want to know the average speed of the object for the total recorded time on the tape. So the average speed means just the distance over the time. We're not interested in these little areas of acceleration and things like that. We simply want to know that right here we wind up at 17.5 centimeters, and we do it over a period of 2.5 seconds. So our average speed is going to be 17.5 centimeters divided by 2.5 seconds. And when we actually work that out, that's actually going to work out to be about 7.0 centimeters per second. Now, we next want to know the velocity of the object versus time. So let's note, across this little chunk here, we have a nice steady velocity. And across this chunk at the end, we have a faster steady velocity. So what that tells us is that if we're looking at a velocity versus time graph, what we should expect is actually a flat level and then a higher flat level. So let's go ahead and eliminate choices that don't have that. That would be choice D, choice E, choice C. And actually that leaves us with choice A, but let's go a little bit further with this. Let's actually talk about why the spike-shaped part is actually a correct part of the graph. So for this first part, we are gaining velocity here. And then we reach a maximum velocity at about 1.5 seconds. So what we would expect at 1.5 seconds is to see a peak positive velocity. And then we slow down to a steady velocity a little bit later on that's faster. So that's why we get graph A as our choice for number 2. And then for number 3, I'll turn the page and just note that we want to get the acceleration of the object as a function of time. And remember, let's remember, if we want to use calculus, acceleration is the derivative of the velocity function, or if you prefer, the slope, if you like to use geometry. So if you remember from the previous page, our velocity function looked like this. And so what that means is at the ends, we need to, and you know what I'm going to do is I'm going to superimpose the acceleration graph in blue here, and we'll say that the velocity graph is red. So if we're looking at the acceleration graph, for this chunk here, we expect 0 acceleration because the velocity doesn't change, as well as here. So we've got 2 flat parts. So we're going to eliminate any acceleration graph that doesn't have that. That'll be choice C gone, choice E gone, and choice D. Now the other thing that matters is look at the velocity here. We've got a positive slope here and a negative slope here. So what that means is that for this part here, we're going to have a nice positive chunk and then a negative chunk down here. What confuses people is the fact that they kind of connect the graphs. So you don't need to worry about these vertical lines. All you care about are the trends here, and the graph that best obeys that is graph A. So really, the parts that I've drawn in blue are the parts that you care about. So that's the answer to number 3. Let's take a quick look at number 4 and 5, and I think that'll wrap it up for this video. So for number 5, we have an object moving in a straight line described by a graph of the velocity v versus t above. And we want to know which is true about the speed of the object during the interval from 0 to 8 seconds. So you know what? Let me just try to figure out what's happening. So if I were to describe this graph, I'm going backwards, and then I slow down to stop. And then at the end of the graph, since my velocity is positive, I then go forwards and speed up. Let's see if anything follows that pattern. So, which of the following is true about the speed of the object during the time interval? It increases during the entire interval. No, it doesn't. It actually slows down from here to here. It's going backwards really fast, and then it stops, and then it turns around and goes forwards and speeds up. It definitely doesn't remain the same. It doesn't decrease during the entire interval. So if we're talking about the speed, it first decreases, as we noted here, and then it increases here. Okay. Decreases and increases, we're talking about absolute value. So it's in fact slowing down here. It's going backwards and slowing down, so decreasing. And then it increases going forwards and speeding up. And then we want to know what's true about the acceleration. Well, let's remember, if this is a velocity graph, acceleration is dv dt. And when we're talking about a linear graph, it's just the slope. So the slope of the velocity graph is a nice, steady, constant slope. So that means it doesn't increase, doesn't decrease, none of that stuff. It remains absolutely the same. So those are the first 5 multiple choice questions, and I'll try to do the next 5 in the next video.